In this video, we're going to talk about factoring polynomials. So we've already talked about how to add, subtract, multiply, and divide polynomials. And so we're going to get to factoring polynomials, which is a technique that is very useful for solving equations that involve polynomial functions, which we'll get to later. And so factoring is the process of transforming a single polynomial into the product of two or more polynomials, all right? And basically what we do is to factor, we sort of use division to rewrite a polynomial as a product of multiple polynomials. And we're going to see that division. Sometimes it doesn't look like we're doing a division, but deep down inside, quote unquote, we're actually going to be doing a division. All right, one of the first methods that I always try to look for when I'm factoring polynomials is to factor out a greatest common factor, or a GCF. And so let's look at what a GCF, or greatest common factor, is. All right, a greatest common factor is a monomial that divides evenly into all terms of a polynomial. For instance, let's just look back at numbers, right? So if I had the numbers 12 and 15, right? Those two numbers have factors, that means numbers that divide evenly into them, and that's other than 1, right? For instance, the factors of 12 include, of course, there's 1 times 12 is 12, 2 times 6, 3 times 4. Those are all the factors of 12, right? The factors of 15 are 1 and 15. You can do 3 times 5. And so those are the factors of 15, right? And so the greatest common factor is the largest number that shows up in both of those lists there. And so 3 is the greatest common factor. And so we want to do a similar thing, but for polynomials. For instance, in this example here, where we're going to factor out the GCF, we have 12x squared and 18x cubed, right? So notice we have a number, a coefficient in both of these terms, and a variable expression, right? And so when I think about finding my GCF, if I look at 12 and 18, look at all the factors of 12 and 18, the greatest one is 6. And then when I look at my variable expressions, well, this x squared is x times x, and this x cubed is x times x times x. And so the greatest common factor between them is the two x's that are multiplied, right? This one here doesn't have a third x, so x squared has to be my greatest common factor. So my GCF here is going to be a 6x squared. Now, the process of factoring, again, is the process of rewriting a polynomial as a product of two or more polynomials. And the GCF is one of the ways that we really see this division that I'm talking about here. And all the other methods, we don't necessarily see the division. But what I'm going to do is and I'm only going to do this in this example. It's a lot of work to show here. But what I'm going to do is I'm going to multiply and divide that expression by 6x squared, right? I can do that because that's multiplying and dividing by the same number. That's multiplying by 1, basically. And so what I'm going to do is, instead of dividing this 6x squared by the 6x squared, I'm going to divide it into this term right here, right? Because when we do a division, only one term or one factor gets divided. So I'm going to write this as a 12x squared plus 18x cubed divided by 6x squared, right? And so I leave this GCF out front. And then what's going in this parenthesis is what I get after I divide each of these terms by 6x squared, right? So notice this is a polynomial divided by a monomial. So we can divide each term by that monomial. And I get that right there. And so let's do some simplifying here. 6 goes into 12 twice. X squared divided by x squared is 1. So I get a 2 there. And here, I get a 18 divided by 6, which is 3, and x cubed divided by x squared is an x. So I get 6x squared times the quantity 2 plus 3x. Now, I don't necessarily want you to go through all of these steps here. I just want you to know where this stuff is coming from. It's not like things magically disappear. We're multiplying on the outside by 6x squared, and then we divide on the inside by 6x squared, and that's how we get these values in that polynomial there. All right. And so this is our factored polynomial. We factored out the greatest common factor. Let's look at part B. Here I have 8a to the 6th minus a cubed b cubed. All right. Let's first find our GCF. And once we find our GCF, we'll factor that out. Now, this has a number 8. This has a number 1. We normally don't want to factor out a 1. It doesn't change anything or simplify our polynomial any. And so what we're going to do is look at our variable expressions. They both have an a to a power. Your GCF always takes the lower power, so I get a cubed. So my GCF here is a cubed. And so my polynomial here equals a cubed. And what I'm going to do is what I want you normally to do is to divide each of these expressions or these terms by a cubed. When I divide 8 to the 6 by a cubed, I'm going to get a 8a cubed. And when I divide this term by a cubed, the a cubes cancel and I get b cubed. All right. And then this is simplified. Now, this is just factoring out the GCF. We're going to come back because this one can be factored further. But since I'm only focusing on factoring out the GCF here, I'm going to stop at this example here. Let's actually get into the other methods that we can use to factor polynomials. All right, so I have a little diagram here that shows some all of our methods that we're going to talk about for factoring polynomials, right? The first thing I always want to think about is factoring out the GCF, right? Factor out the GCF. No matter what polynomial you have, try to factor out a GCF if you see a GCF in that polynomial. All right, after you factor out the GCF, you're going to look at the number of terms that your polynomial has, right? Your polynomial can have 2 terms, 3 terms, or 4 terms. All right. And we're going to start with the polynomial with 4 terms because the factoring method is very related to a GCF. All right. By terms, I mean the actual variable expressions that are separated by a plus or a minus sign in your polynomial. For instance, in these 2 examples here, we have polynomials with 2 terms. I had an 8 to the 6th minus an a cubed b cubed. So that's 2 terms. The first term is here. The second term is here. This one also had 2 terms. The first term is here. The second term is there, right? So when we have a polynomial with 4 terms, we factor by grouping. I don't have the steps to factoring by grouping, but basically we're going to group these 4 terms into 2 separate sets of 2 terms. So I'm going to look at an example just to show you here. Let's say I had 14x cubed plus 7x squared plus 4x plus 2. All right, I just made that up on the spot, right? So this polynomial has 4 terms, right? So what I want to do here is what I'm going to do is I'm going to factor by grouping. I'm going to group the first 2 terms together and the second 2 terms together, right? From these first 2 terms, I'm going to factor out the GCF. My GCF, if I look at those 2 terms, is 7x squared. From the second 2 terms, I'm going to factor out the GCF as well. And in those terms, my GCF is 2. All right? And I see here that you guys can't see that fully, so I'm sorry about that. But you see I factored out, or I looked at my GCF, which is a 7x squared and a 2 for the second 2 terms after I grouped them 2 by 2, all right? And so what I'm going to do next is I'm going to factor out the GCF, right? So if I factor out the GCF of these first 2 terms, I'm going to get a 7x squared. And what I'm going to be left with is a 2x plus 1. And when I factor out a 2 here, I'm going to be left, I factor out my 2, and I'm going to be left with a 2x plus 1. So I group, the reason why we say factor by grouping is because we group 2 by 2. We have 4 terms, we group 2 by 2, and we factor out the GCF of each of the groupings. Then we look at this thing here, and now we have 1 term here and 1 term here. So now we have a polynomial that went from having 4 terms to a polynomial that now has 2 terms. And now with that 2-term polynomial, we can say that its GCF, notice this 2x plus 1 here, and that 2x plus 1, I know it's a polynomial, but that 2x plus 1 is actually a GCF. So I can factor out that GCF, which is that 2x plus 1, And when I do it to this first term, I'm going to be left with the 7x squared. And when I do it to the second term, I'm going to be left with the 2. And that's how we would factor when we have a polynomial with 4 terms. All right. When we have polynomials with 3 terms, there are 2 methods that we're going to use to factor, right? And it depends on the way the polynomial with 3 terms looks. All right. For instance, I have an x squared plus bx plus c. So polynomials that can be written in this form are going to be factored this way. And if I have a number a here other than 1, so notice here, there's a 1 understood to be in front of the x squared or the squared term. Here, this a does not equal 1. It's some other number. When there's a 1 in front of the x squared, we're going to find 2 numbers that such that st means such that their product is c, so they multiply to give you c, this number here, and their sum is b. They add up to that number b there. And then we factor into a product of binomials. So it'll be like x plus or minus some number, x plus or minus some number. All right. Here, when the a is not equal to 1, it's a bit of a longer process to factor. And there are many ways to factor these types of polynomials. Now, I'm going to show you the way that I recommend that you factor. But if you already know how to factor these, you do it your way. I don't really care what way you know how to factor, just know how to factor these things here. I'm going to show you this way here, all right? We're going to find 2 numbers such that their product is a times c. Notice the difference here. The product here was c. The product here, the number that you're going to be looking for, has to be a times c. So you take that leading coefficient and multiply by that constant term. Whatever that number is, you find 2 numbers whose product is that number. And then their sum is the the b value here. All right. Then we rewrite the bx term using the 2 numbers that we just found. We factor by grouping because we're writing using 4 terms, and then we're going to have a product of 2 binomials similar to here, but it's not just going to necessarily be an x and an x. It may be a coefficient with the x's here. And then we have polynomials with 2 terms. There are 3 methods that we use to factor. There's a difference of squares. So if you notice that the first term is a perfect square and the second term is a perfect square, you multiply, you factor by doing the root, the square root of the first term, put it in the first slots here. You do the square root of the second term, put it in the slots there. You separate it with a plus and a minus. There are similar formulas for difference of cubes. Those formulas are given here. All right. And so let's look at some other things that may help us factor, some other patterns here. The left side of each of these equations are in factored form. And so what we want to be able to do is look for what's on the right-hand side, the patterns that we see on the right-hand side of these equations here, in order to help us factor when they're written in this form right here. And so these are some formulas that you may use to help you factor things that are a little bit more complicated and may have some bigger numbers and things of that nature. All right, let's look at some examples so that we can get used to this. And then we're going to see a lot more examples in class. But let's say factor completely. Part A, x cubed plus x squared minus 7x minus 7. I want to factor this polynomial here. So the first thing I'm going to think about is to factor out the GCF, the greatest common factor. If I look at all of those terms, there is no greatest common factor besides 1. And so now I count up the number of terms I have, and I see that I have 4 terms. My method for factoring when I have 4 terms is factoring by grouping. So I'm going to group the first 2 together, group the second 2 together. Out of my first 2, I have a GCF of x squared. Out of the second 2, I have a GCF of 7. All right, and so my polynomial, when I factor the GCFs out of those groupings, I get an x squared. I'm going to be left with an x plus 1. And here, I know that my GCF is 7, but this is something that I always do. When my GCF or my leading term of the expression that I'm going to factor is negative, what I'm always going to do is I'm going to factor out a negative GCF value, all right? So instead of factoring out a 7, I'm going to factor out a negative 7, which I'll write it as a minus 7. And basically, that's going to change the signs of those terms inside, and I get what I get when I divide by 7, right? And so now I have two terms, and both of them have an x plus 1 in them. And so I factor out that x plus 1, and I'll be left with an x squared minus 7. Let's go to part B. I have n squared minus 8n plus 7. Again, the first thing I'm going to think about is the greatest common factor. My greatest common factor would be 1. And so I don't have a GCF in this example. I count out the number of terms. There are 3 terms. I have a squared term. Notice the pattern. This is something squared. This is something linear. And this is something constant, right? And so when I have that and I have a 1 in front of my x squared or my squared term, I can immediately factor. I know that this is going to be an n here and an n here. I have to find two numbers that multiply to give me 7, but add up to a negative 8. Well, I only have a 7 and 1 that multiply to give me a positive 7, but also negative 7 and negative 1 also work. And those actually add up to a negative 8. So I'm going to use the negative 1 and the negative 7, and that is my factored form here. Let's do another example. 18x squared plus 15x plus 2. I want to factor that completely. I have 18x squared minus 15x plus 2. There's no GCF. I have 3 terms. Notice when I have this 3 terms, I have a squared term here, a linear term here, and a constant term here. But, if you notice, I have a number in front of the x squared. And so let's talk about how we can do this. What I'm going to do is I'm going to multiply the 18 and the 2. 18 times 2 is 36. So what I want to do is I want to find two numbers that multiply to give me 36, a positive 36, but add up to negative 15. Now I'm thinking about the numbers that multiply to give me 36, right? Some numbers like 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, right? Now they have to add up to a negative, so both of them are going to be negative, right? So I'm going to put negative signs here. And basically, I want to pick the pair that add up to negative 15. Well, if you look, negative 3 and negative 12 add up to negative 15. And so what I'm going to do here is I'm going to rewrite this bx term, this negative 15x term, using a negative 3x and a negative 12x, all right? And so what I'm doing here is I'm creating a polynomial with 4 terms instead of using the 3 terms that I have there. And now when we have a polynomial with 4 terms, we know that our only method of factoring is to factor by grouping. And so my GCF of my first 2 terms is 3x, and my GCF of my second 2 terms is 3. So I'm going to factor out my GCF. I get a 3x. I'm going to be left with a 6x minus 1. And here I factor out a 2, but I'm going to make it a negative 2 since this leading is 2, negative. And so I get a 6x minus 1 when I divide both of these terms by a negative 2. And now I have 2 terms here, and they both have a 6x plus a 6x minus 1 in them. When I factor that out, I'm going to have a 3x minus 2. And so there is my factor form there. Again, there are other methods that you may use to factor a polynomial that looks like this. I like to use this method because I can get partial credit on the test. I can show my work and things of that nature. So this is the method I recommend. Some of these other methods use some things that disappear and then you bring them back, and it's easier to forget that when you get on a test or a quiz. So I don't recommend some of those other methods, but do what you like as a student and an expert, right? Last but not least, we have 1 minus 8a to the 6th, right? Now with this example, I don't have a GCF and I have 2 terms, right? And so I'm going to kind of focus on what happens on these 2-term situations here. Notice I had a 1 minus 8a to the 6th. So I'm going to go back to that chart there. And I only have 3 methods that I know to factor when I have 2 terms. And notice that was a 1 minus 8a squared, a to the 6th. All right, it can either be a difference of squares or a difference of cubes. Since that wasn't a plus sign, it's not a sum of cubes. So it's either going to be this one or this one. So the way we tell the difference is to look at whether we have perfect squares being subtracted from each other or perfect cubes. Well, 1 is a perfect square and a perfect cube. 8 is not a perfect square, so I'm not going to use the difference of squares formula. I'm going to use the difference of cubes. 8 is 2 cubed, and I can actually write 8 to the 6 as a cube. So what I'm going to do is I'm going to rewrite that formula. So this is something that you have to memorize, right? A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And so if I look here, the thing that I'm cubing to get 1 is 1. And the thing that I'm cubing to get 8 is 2. And what I cube to get a to the 6th is a squared, right? Because if I raise a power to a power, 3 times 2 is 6. And so I'm going to put the 1 in for this a here. And I know this is weird. I'm going to put the 2a squared in for b. And so my polynomial in factor form is going to be a 1 minus 2a squared, there and there, times a 1 squared plus a 1 times a 2a squared plus a 2a squared squared. Okay? And that would just simplify 1 minus 2a squared, 1 plus 2a squared plus 4a to the 4th. And so what we can do in all of these examples, if we wanted to check our work in our factoring, we could just multiply everything back out. I'm going to do that for this example and this example only because sometimes these can get a little confusing, right? So I'm going to multiply the 1 by all of the terms there, and then minus a 2a squared times all of the terms. All right, and this is me checking. All right, well, 1 times anything is that anything. But then I have a minus 2a squared times 1, which is that, minus a 4a to the 4th, right? 2 times 2 is 4. A squared times a squared is a to the 4th. And then I'm going to have a minus a 8a to the 6th. And notice here we have some terms that cancel. The 2a squared and 2a squareds cancel. 4a to the 4th cancel. And we have 1 minus 8a to the 6th. All right, that concludes this video. There is a lot more that we have to talk about with factoring. This is just an introduction to get you started.